Hi grade 11s, we're on to topic 3, which is converting between nominal and effective interest rates. So this is quite closely linked to what we were doing in topic 2 because we'd already started the kind of idea between converting between the two. Now just a quick recap, what makes something a nominal interest rate and what makes something an effective interest rate? An effective interest rate is where your time periods match. So for example, if you say per annum, if you give the interest rate per annum, and then you say compounded annually. Now, as I said in the previous topic, they never quote interest rates in any other way, really. And so that's pretty much all we think of as an effective interest rate. But basically, anything where the time periods match is considered effective. So per month, compounded monthly would be considered effective. But we never really do that, so I wouldn't worry about it. So a nominal interest rate is where your time periods do not match. So if I give you an interest rate per annum, but then compounded monthly or compounded quarterly, anything like that, that is a nominal interest rate. So per annum, but then compounded, and the most common ones are monthly, semi-annually, or quarterly. So now what we need to be able to do is convert between these. So can you convert between an effective interest rate and a nominal interest rate? And the reason why this is important is if we can't convert, we can never compare. So if you go to a bank and one bank says they're offering you 12.2% compounded monthly and the other one says they're offering you 12.5% but it's compounded quarterly, how do I know which one is a better return on my investment? So let's have a look at this. Example 1 says convert 11% per annum compounded quarterly, so that makes it a nominal interest rate. Now it doesn't really matter, but just for being technically correct, that's a nominal interest rate. Convert this to an effective annual interest rate. So we want a per annum compounded annually. Now the most important thing when they ask you to convert, when we're saying convert, is what we're saying is we want you to find an interest rate per annum compounded annually that has the same effect as 11% per annum compounded quarterly. As in, if you put 100 Rand into both those accounts, you would get the same amount out. So that's what's really important. This question is saying, what effective annual interest rate has the same outcome as 11% per annum compounded quarterly. So I'm going to leave that part out. But basically, what effective annual interest rate has the same outcome as this 11% compounded quarterly? Now, there's two ways to do it. So I'm going to divide my page in half. And, people prefer both methods. It's like 50-50 split. I do think one of the methods is the easier one. So let me show you the easier one. So the first method is to basically say, well, let's take 100 Rand and let's put 100 Rand into an account for 1 year. And let's add interest on the interest that was given to me. So let's take 100 Rand for 1 year at 11% per annum compounded quarterly, because that was what was given to me. So I always do 1 year, because as long as you're comparing the same time periods, it actually doesn't matter, but 1 year is just so much easier. So we take 100 Rand, it's 11%, but careful, it's compounded quarterly, so that means it's divided into 4 parts, and because you're always going to put it in for 1 year, these numbers are always going to match, because if you're dividing 11% into 4 parts, 1 year you will have 4 sets of that interest. So for 1 year, those 2 ends will always match. So if I work this out, it'll tell me how much money I'd have in my account for 100 Rand investment. And I get 111 Rand 4621259. Okay, now the question is, how do I put in 100 Rand and still have the same outcome but interest once a year? So my question is, how can I get out this same amount from 100 Rand but with an interest rate compounded annually. So this is the method that we were working with in topic 2, because we were kind of just playing around, and this is what we were working with. We were saying, right, how do I get out 111 Rand, 462, I'm going to leave out the rest, from 100 Rand if interest is compounded once. So I could divide by 1, but there's no point. So it's just an interest rate, and careful, it must be for 1 year, because you can't compare different time periods. And so I would divide by 100, and I would minus 1, and I will get 11.46% is my interest rate. Now this is slightly bigger than the 11%, and it has to be, because the 11% compounded quarterly meant that you would get interest on interest every quarter, whereas this interest rate is compounded annually. So you just get interest once. And so you have to make up for the fact that you don't have interest on interest. So this is probably the easier method. It's the idea of you put 100 Rand in for 1 year at what you were given, and then you say, right, how do I get out that same output from 100 Rand with the interest rate I'm looking for? And here that interest rate was a compounded annually, so it was once a year. So what's my second method? The second method is working on the same idea. What this is saying is you want your A value for your nominal interest rate. So that means your final amount. So basically your final amount, which we already know is 111 Rand, 46. You want that equal to your final amount of your effective. So it's on the same idea. It's saying that this final amount on my nominal, I want it equal to the same thing as the final amount on my effective. Now, how do you work out your final amount on your nominal? You would say 1 plus my interest rate to the power of n times p. And how do you work out your effective interest rate? You'd say p times 1 plus I to the power of n. So basically you'd use the formula. Now, the reality is I was using 100 Rand. So I was putting 100 Rand in, I was putting my interest rates, and I was saying 4 in that first calculation. And then I was using 100 Rand again in my second calculation. So if you look at it, these p's are the same. They're both going to be 100 Rand. So if I divide by p on both sides, because they're the same p, they basically end up cancelling out. So what you always get then is 1 plus I to the power of n from the nominal side must be the same as 1 plus I to the n on the effective side. Now that kind of makes sense, because on both sides you would just be multiplying that bracket by 100 to get the same answer. So basically, if I equate these, I can directly get to my interest rate. So let me show you what it means. What it means is if I take my left-hand side, and my nominal interest rate is 11% compounded quarterly. Now, remember, we're always comparing 1 year. So you would get interest 4 times in that year. Now, you want that to be equal to 1 plus an interest rate once in the year. So I don't even have to bother writing that. And you would get interest once in the year. So now, if I work this out... dropped my pen. So if I work that bracket out, I get 1,114,621, and it's equal to 1 plus I all to the power of 1, not that that 1 matters. Now, that kind of makes sense, because if I look, I'm meant to get out 111 Rand and 46 cents. So the only difference here is that I actually haven't multiplied by the 100. Now, I would minus 1, I would times by 100, so I'd get rid of this 1, and then I'd times by 100, and guess what? I get 11.46%. So personally, I prefer the second method, but lots of people find the first method more logical. So with each of these examples, I'm going to do both methods, and you can decide what method actually works for you. Everyone's different. Okay, let's try another one. This question says, convert an effective annual interest rate of 14.2% per annum, so that means it must be compounded annually, to a nominal interest rate compounded monthly. So this is a little bit of the opposite, but we follow exactly the same method. So the first method is, I'm going to say, if I take 100 Rand at the interest rate I've been given 14.2% compounded annually, so I'm not going to divide by anything because it's once a year, and for 1 year, because we always compare 1 year with 1 year. So I would get out an output of 114 Rand and 20 cents. So now we say to ourselves, ourselves, how can we get out that same output? How can we get out 114 Rand and 20 cents from 100 Rand, except now my interest rate I don't know, and I want to compound it monthly. So I want to take this interest rate and divide it into 12 equal portions, and then if this was 1 year, I would get interest 12 times. So just have a look at those. Those match because you're always comparing 1 year and 1 year. So now I just have to kind of solve this. So I'm going to divide by 100 on both sides, and I get 1,142 is equal to 1 plus I over 12 to the power of 12. So I would now 12th root both sides, and I don't actually have to write this down, but just so you know what we're doing, it's 1,01126 blah blah blah, and that's 1 plus I divided by 12. So I'd minus 1 on both sides, so I get 0,01126 blah 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 is I over 12. Then I'd multiply by 12 and multiply by 100, because you need to write it as a percent. And so when I do that, I get 13.35%. Try to use the answer button on your calculator a lot. Now, what would I actually write down in an exam? I generally show these two lines, and then I show my first line, and then to be honest, I jump straight to my answer, and I do my whole divide by 100, minus 1, times 12, 12th root, all those things. I just do that on my calculator, kind of step by step. But especially as you're getting used to it, it helps you to write down some steps. Now, why is this interest rate less than the 14.2? The 14.2 was an effective interest rate, so you were getting that interest once in a year, whereas this interest rate, you're going to be getting interest on interest 12 times in that year, and so automatically you will earn more money. So this interest rate is less because you automatically earn money to catch up to that 14.2%, simply because you're getting interest on interest. So if you walked into a bank and they offered you an effective interest rate of 14.2% per annum or 13.35% per annum compounded monthly, they've offered you exactly the same thing, because these two things have the same effect on your money. Okay, now what was the second method? The second method was, I always say, right, 1 plus I to the power of n has to equal to 1 plus I to the power of n. Now what have I been given? I've been given 14.2%, so compounded annually, so divide by 1 basically, for 1 year, and I'm trying to convert that to an interest rate compounded monthly for 1 year, which would be 12 months. So if you work this out, you get 1.142, which equals 1 plus I over 12 to the power of 12, and you'll notice that's exactly the same step as there. Now it's the same step because here, how do I get to that point, is I just divided everything by 100, whereas I've kind of pre-done that in the second method. So now I would do exactly the same logic. I would 12th root, I would subtract the 1, I'd times by 12, and I'd times by 100, and I'd get exactly the same answer. So they are exactly the same method, just presented in a different way. Right, let's have a look at this one. Which interest rate will earn you more money over 1 year? 10.5% per annum compounded annually, or 9.8% compounded quarterly? Now, don't be fooled by the fact that this is less. It is compounded quarterly, which means you're getting interest on interest multiple times in the year, whereas this 10.5% is just once off. So who knows whether that's big enough to compensate for the fact that you're not getting interest on interest. Now, if you're trying to compare, I either need to convert 10.5% to compounded quarterly, or I need to convert the quarterly, I need to convert the 9.8% to compounded annually, so convert to an effective interest rate. Now personally, I always prefer converting to an effective interest rate because I don't have to worry about dividing by anything. And so actually I'm going to take this 9.8% per annum compounded quarterly and convert it. So let's look at our two different methods. Method number 1 was taking 100 Rand in and putting it in for 1 year. So I'm going to use 9.8, just be careful, that's 0.98, compounded quarterly for 1 year, so that's 4 quarters. So I get out 110 Rand and 1660685. So then I say to myself, right, how do I get out 110 rand, 1660685 if I put in 100 rand, but I only got interest once in a year? So it's I divided by 1, basically, for 1 year. So I would divide by 100, I would subtract 1, I would then multiply by 100 to get a percentage, and you will get 10,17% is I. So just to tell you how I got that, I divided by 100 on both sides, then I got rid of the 1, and then I had to get a percent. So I times by 100. So what is better? Well, definitely not the quarterly, because that's less than 10.5%. And so definitely, so which rate will earn you more? Basically, 10.5% compounded annually will earn you more money. Now, I could have converted the compounded annually one, but this was definitely easier. Now, let's look at our second method. Our second method is saying, well, 1 plus I to the power of n has to equal 1 plus I to the power of n, the two different situations. So compounded quarterly was 0,098, compounded 4 times a year, so it's 4 times a year. And that I'm trying to convert it to an effective interest rate, so it's divided by 1 for 1 year. And if I work this out, it's a little bit more tricky because I've got to actually do the calculation. I can't see what it is, like I could in the previous example, but I get 1,10166, blah, 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 and that equals 1 plus I. So I'd subtract 1, and I'd get 0,10166, blah, 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 and I times by 100. And so what do you know? I get 10.17%. So it leads me to exactly the same answer. So just pick a method that works best for you. Right, let's have a look at example 4. Example 4 says, Chris invests 10,000 Rand on the 1st of May 2006. By the 1st of January 2010, this amount has risen to 18,500. The nominal interest rate is X% per annum compounded monthly. Calculate X. Right, so my first question, I clearly need to be using my formula, but I'm definitely going to have to write myself a shopping list here. So my final amount, my accrued amount is 18,500. I started with 10,000 Rand. I don't know what my interest rate is, but it's compounded monthly, so I must divide by 12. And now I've got to figure out how many months it is. And this is where drawing yourself a picture helps a lot. So you have the 1st of January, then you have the 1st of February, then you have the 1st of March, April, May. So all the way up to December. So on the 1st of May, how many months would it have been in the account for that first year? So in 2006, how many months would it have been in the account? Well, I put it in on the 1st of May, and there's 12 months in a year. So how many months, I actually find it easier to count in this example, how many months it wasn't in the account. So it wasn't in the account for the whole of January. Then it wasn't in the account for the whole of February, it wasn't in the account for the whole of March, and it wasn't in the account for the whole of April. So there are 4 months that it was not in the account. So which means that in 2006, it was in the account for 8 months. Now you've got to be a little bit careful here, because we often think of May, oh, that's the 5th month, so for 5 months it wasn't. But just be careful, it said the 1st of May. So it was in the account for the whole of May, the whole of June, July, August, September, October, November, December. So that's 8 months. Then in 2007, it would have been in the account the whole year. So that would have been 12 months. In 2008, it would have been in the account the whole year, which is 12 months. In 2009, it would have been in the account the whole year, so that's 12 months. And in 2010, it wasn't in the account at all, because this is the 1st of January 2010. And so actually, it's 12 plus 12 plus 12 plus 8. That's the amount of time it's in the account. So 12 plus 12 plus 12 is 36, plus 8, it is 44. So it's 44 months. Now it's worth taking time to figure that out, because obviously that's going to make or break my question. So I now have 18,500 from 10,000 Rand. My interest rate is, I don't know, but it's compounded monthly. You must divide by 12, because otherwise you're going to be saying you're getting that interest rate every month. but you've actually divided it into 12 portions, and it's 44 months worth. So I would take my 18,500 here and divide it by 10,000, which gives me 1,85. And now we need to do the 44th root of both sides so that we can get 1 plus x divided by 12 by itself. So 44th root, my answer. You don't actually have to write this down if you don't want to in an exam. I get 1,01407 blah blah blah. So now I'm going to subtract 1 and I'll get 0,01407 blah 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 equals x divided by 12. And finally I'm going to multiply by 12 and then I get 0.168, which is weird because that's not a percentage. So don't forget to multiply by 100 to get 16. Now it's 895. So it actually rounds, the 5 rounds the 9 and the 9 rounds to 10. So this actually becomes 16.90% per annum compounded quarterly. Compounded monthly. And so B's question now says what we've been practicing. Can you calculate the effective interest rate? So basically what they're now saying to me is, can I convert 16.9% to an effective interest rate? So the reason why I've asked this question is that lots of people now think that I need to use the 44 months and how many years is that? Absolutely not. Whenever you are converting, we compare 1 year and 1 year. So we say, if I put 100 Rand in at 16.9% compounded monthly for 1 year, so that's 12 months. So completely forget about this question. Don't use the 44 months, don't use the amount of 10,000. Literally do exactly what you normally would have done. And I get 118 Rand and 27,249. Now how do I then get out 118,27249 from 100 Rand if interest was compounded once in the year, one time? So I divide by 100, I then minus 1, and I times by 100 to get a percent, and I get an interest rate of 18.27%. Now once you've done this quite a number of times, you start realizing that when you're converting into an effective interest rate, you can actually always see it in your outcome. Because if 100 Rand suddenly grew to 118.27, I can see what interest I earned. I earned 18 Rand 27 interest, which means my percentage is 18.27 effective. Now that only works for when you convert to an effective interest rate. So the other method, just to show you method number 2, let me just get a different color, would be if I said, right, 1 plus I to the power of n equals 1 plus I to the power of n. So what was I given? I was given 16.9% compounded monthly for 1 year, so that's 12 months. And that's going to be equal to 1 plus I once divided by 1 to the power of 1. And so if I work that out, I subtract 1, I multiply by 100, I get exactly the same answer. So always just pick what method works for you. But most importantly, don't think that you need to use anything from the question. The question basically is convert that to an effective interest rate. So let's look at our last example. Example 5, convert 13% per annum compounded monthly to a nominal interest rate compounded semi-annually. So far we've been always converting from nominal to effective or effective to nominal. Now there's nothing wrong with converting nominal to nominal, and it's exactly the same method. So our first method is exactly what we would normally do. We'd take 100 Rand, I'm going to put it in the account at 13% compounded monthly for 1 year, so to the power of 12. So that gives me 113 Rand, 8032482. Don't forget to keep all the decimals. Now just out of interest, I can clearly see that that means an effective interest rate of 13.80%. But that's not what they asked. They said, how do I get out 113,8032482? So same output if I started 100 Rand, but now the interest I'm looking for isn't per annum compounded annually, it's divided into 2 parts because it's semi-annually. Now this is still 1 year, so this is to the power of 2. So it just means that when I work backwards now, I'm working backwards to another nominal interest rate. So I would divide by 100 on both sides, and I get 1,138 8032 blah blah blah, and now I'm going to have to square root both sides, which gives me 1,0667 86 something something something. And sorry, I forgot my squared off there, I see. And now I would subtract 1 on both sides. I would then multiply by 2 and then multiply by 100 to get a percentage. And I get 13.36%. Now that would be per annum compounded semi-annually. So you've converted between two nominal interest rates. So it's exactly the same method. Now let's just check whether this makes logical sense. So 13% compounded monthly, it's bigger compounded semi-annually. Now that makes complete sense because you're only getting interest twice in the year. So you're only getting interest on interest twice. Whereas with monthly, that would be every month. Okay, now what's the other method? The other method is equally as similar to the past. Basically, I know my two brackets have to be equal. So I know that 13% compounded monthly for 1 year has to now equal some interest rate compounded twice a year, so that would be an exponent of 2. And so I get a very, very similar kind of calculation. So if I work that out, I get 1,138032 equals 1 plus I over 2 to the power of 2. And you will notice that's exactly the same as there. So I would now square root both sides. I'd subtract 1, multiply by 2 and multiply by 100, exactly how I did in the previous method. So they really are related. Okay, so that's the end of this topic. It's a really important one, being able to convert between interest rates in the real world, because you're often, when you buy a house and you're faced with different options of interest rates, you need to be able to convert to the same kind of base so you can tell which one's better for you.